Good guys. Today we're gonna be solving time-based key value store. I'll be blind solving this. I never seen it before. Let's go ahead and try to read the question. So we got to implement a time-based key value data structure that supports storing multiple values for the same key at the specified timestamps. Retrieving the key's value at a specified timestamp, we have to implement the time map class. Looks more like a design question. Okay, let's go ahead and read this. So we go ahead and initialize the object, that's time map, and then void key string value into timestamp stores the key with the value at the given timestamp. Okay. String get string key in timestamp returns the most recent value of key if set was previously called on it and most recent timestamp for that key previous stamp is less than or equal to the given timestamp. If there are no values, it returns just an empty string. Okay, for calls to set, the timestamps are in strictly increasing order. Okay. Because they're strictly increasing order, we could assume that the more timestamps we enter, the greater each of those timestamps are going to be increasing. So I can already see how this is a binary search question. Okay, so we have to first initialize this. Seems like we're looking for, yeah, key value pairs. See, because key and then a value. So let's go ahead and just call that, um, see, we got Alice happy one, Alice one. I'm guessing it's like someone's name, and then their mood, and then a number. Okay, I'm gonna say name, name to mood. Okay, let's go ahead and name that. I'm gonna name it name to mood. Let's go, and we know that this is going to be a dictionary, because we see the key value pairs right here. So we could just go like that, and we actually do self dot self because we're initializing. It's a design question. Okay, and we have this, and this should be actually a the key. Key should be like someone's name, and the value is actually going to be a list. So the value is going to be a list of, it's going to be their mood, then it's going to be their timestamp. Okay, okay, so now this right here, it won't return anything. So this is called set. This is kind of this function will set the mood. No, the name to mood. Okay, so we're given a key, we're given a value, and we're giving a timestamp. Okay, so let's go ahead and call it name to mood at this key is going to be equal to, it's going to be equal to, it's going to be equal to string. Well, it's going to be equal to the value and the string, the timestamp. But we kind of just append things because we could have a key, we could have multiple of the same key. Then from there, we just append a bunch of timestamps. So we're gonna do say, I guess we'll have like a set called like name. Actually, no, we don't have to. We could just say, actually, I think we could just append, right? Maybe make a default dictionary. Hmm, I don't know. I think it's a simplified. syntax right now. Let's just go ahead, just implement this part. So we have to get, we have to get what do we have to get? Let's see. So get returns the most recent value. We have to get key value, the most. Oh, okay. So you said get the most recent value based key. So I'm trying to get Alice one. So time map is calling once. Set is the next call. It sets it. Alice happy one. So it returns the most recent value of. Okay. So we just get the value, which is on that timestamp. If value not there, get the most recent. Then also we could say that if there is no value, we could go ahead and just return empty string. Okay, let's go ahead and code this up. Okay, so we're given key, and we kind of just look at the timestamp. Okay, so look, we use the key, so um, call this. We actually get this right here. So this is actually going to be a list, but we have to look through that list. Okay, let's just check if they even have if not this return, just like an empty string. Else, then we could run our binary search. So it's got to get each value. So we run a binary search. Okay. And then we could say for each mood in moods, we could say if, well, each mood is actually two things. Mood of mood is a list, mood, comma, timestamp. So, okay, if timestamp, which is the timestamp that they gave us, is less than, shit, less than, so just call mood in position two, which is just going to be called one. Then we go ahead and just return mood zero, which is the feeling that you felt at that time. And, and then else if stamp is, let's say it's less than mood at position one, then we know we have to increase it. So, oh, let's go ahead and write our pointers actually. Let's call this left pointer. Right pointer is going to be the length of moods. But we went ahead and get the moods first. I'm gonna blow my nose real quick. Oh, all right. Okay, so right pointer's that. So now we actually go do run our binary search. So how do we do this? Okay, we see stamp. Okay, if it's too small, then we want to go ahead and increase it. Let's go ahead. Actually, we have to call. Oh, we can't just look through every mood. We have to do that lot. Right pointer, left pointer. Well, left pointer is going to be equal or less than or equal to right pointer. We're gonna have to calculate the middle. Left pointer plus right pointer. And we just divide this by 2. Now for each mood and moods, but we don't do this actually. We go ahead and just go by pointers. So you could just say if moods at middle, okay. We go to mood 1, we can just return mood 0. And for this, we just go ahead and just switch the condition for moods middle. This is basically the timestamp. Wait a minute. We go ahead and actually switch this side. Timestamp's the target that we're looking for. Ah. Mm. It's actually moods of this mood, which is going to be middle, because it's going to be a nested list. So mood middle, we'll go ahead and get you that current mood, and then in there, yep, yeah, it should be like this. And we want to actually return that and compare this. So mood, yep, there you go. So if you want to increase it, if timestamp is smaller than mood at the middle, um, if timestamp is smaller, I think it's easier for me to visualize if I say if the mood middle. Yeah, I'm just gonna do it this way. Greater than the timestamp. That means we have to go ahead and decrease our middle. So we could do that by doing right pointer is actually equal to middle pointer. Actually, we just call it middle minus 1. And then else if moods at the middle. And since we're looking at 1, which is our timestamp, let's say it's less than timestamp. Oh yeah, we already have this, our checker, okay. And we could just do left pointer is equal to middle plus 1. And if none of this actually works, we could just return, say we finish this, left is equal to right, we could just go ahead and return. Well, we just want to do the most recent one. Hmm. My intuition is telling me that it should be on left pointer. So let's go ahead and just do that. So I say return moods. Moods at middle. Moods at actually left pointer. And we return the mood, which is 0. I think this should be actually good. I think I might have to fix up this syntax, but this is generally the right idea. Let's go try and fix the syntax. See, how do I initialize a dictionary? Okay, let's go ahead and solve that. Self. Oh, self comes first. Key is a name. Key is going to be equal to name. Value is going to be equal to a list of mood, comma, int. Okay, and value will be a list of lists. Yeah, like DAX actually. That's what I thought. That's pretty good. Okay, let's go ahead and do that. Okay, we can just run. Okay, so this is good. Name to mood. And now we're gonna say if key not in name to mood. Is that it? Ah, okay. Then we go ahead and add that key then. We could say name to mood at this key is going to be equal to, yeah, then we just do this. Self.data name. Okay, I think we just append. And we just go ahead and append whatever we want. Let's go ahead and append our, oops, go ahead and append our value and our timestamp. All right. Oh, wait. Append subject. Okay. Yeah, okay, that's what I did over here. And that looks good. This looks good. I think this looks good too. Okay, let's go ahead and run. Let's see. Oh, and we got equal equal line 34. Let's go ahead, check it out. Yeah, it is equal equal. Let's go ahead and test it out now. And we're into an issue. Name to mood is not defined. Ah, there you go. Okay. Name. Oh, self dot name that mood. Okay, what's the next error? If not, name to mood. Ah, I forgot self. And it needs self dot here. Okay, looks like we got something else. So name to mood at this key dot value. Okay. Now work on that syntax, yo. Values equals self dot data. Self dot data. Self dot this. Oh, I don't even put values here. Yeah, I think this is it. And okay, now we have one right here. What is it? What's the error? Mood is, yep, forgot. It's moods with an S. Did I make that mistake anywhere else? Nope, looks good. And okay, yeah, it is right here too. And looks like, okay, what is this? Timestamp. Put an S, lowercase this S. And okay, what is it this time? Capital S again? Okay, let's run it again. And okay, left pointer. What if I just say middle? Hmm. I think we'll actually have to return just like the first value. Hmm. Ah, okay. Let's go ahead and check this. Hmm. If not self-to name key. Thought we're supposed to return the latest, but okay. There's something about my search right here. If we can't find it, then it just throws an error. Oh, check if key exists. Oh, I see. think it's a return line. So, yeah, what would it be in the key? Why would I check the values for that, right? Oh, yeah, you got infinite time? No, no, happy blank. Should have been happy again. What the hell? We should have a resolve variable. What the hell? Hmm. Ah, you combine these two. Moves at middle, and then this gets position 0. I think this should work. And yep, we did it. Let's go. Mm. All right, I think I know how to answer this question now. Um, I think the my weakness when solving this question was actually just knowing the syntax for creating this one, creating the dictionary. I think this is a really interesting thing that I didn't notice. I'm just kind of making the key. I think I would use default dict, but I wouldn't really know how to use that in this situation. So that's why I just said if key is not in this, then go ahead and make that. It's making this a key if it's not there, and just appending if it is there, right? It'll append it. I think that's nice to know. Definitely gonna have to know that this syntax right here. And if key not itself to main, okay, I think I knew this already. Left pointer, making this little result thing was pretty smart. Making the result right here and just kind of updating the answer as long as it has satisfied the condition. Returning this if it was actually what we did to get it correct. Other than that, it was a pretty basic question. I would say this is on the easier end of medium questions. It did take me long the first time just because I'm learning the syntax, but good. I like this question a lot, actually. Go ahead and stop sharing my screen and see you guys later. Thank you for watching.